All right, we're live, all the way live from Zoom. We're looking at today, it's very similar, guys. It's very similar to what we looked at on Tuesday. Because on Tuesday, we had arithmetic sequences. Here we have geometric. Okay, geometric often is going to be speaking about a multiplying kind of aspect, a multiplying or dividing aspect. Okay, so everything here for today, instead of add, subtract, now it's multiply, divide. Okay, that's the key difference. Everything else is very, very similar. Okay, that's why I don't mind throwing this in right before break, because it's so similar, it actually makes sense to put it in here. Okay, so let's look. This is just kind of the warm up for it. Now, we have these terms, right? And if this was an arithmetic sequence, I might say, well, we added 2. Uh-oh, we didn't add 2 here. And you'll be able to tell if it's geometric because you'll be multiplying to get to each of the next terms. These are just terms. So we got a sub 1, we have a sub 2, and so on. These are just the terms. Remember, it's a sub number. It's below. It's not an exponent. It just reminds me that that's term 1, term 2, term 3, and so on. So what number comes next? Well, what is the common ratio? Before we had the common difference, what is the common ratio? How did we go from 2 to 4? Perfect. Yancy, perfect. You multiply by 2. Good, Abby. Good, Janice. All right. Here, all we have to do is multiply by 2. Now, if it's really hard and they aren't such easy numbers, what we can do to find our common ratio, add this to your notes. The common ratio denoted by R, what we can do is we can divide the next term by the prior term. So this would be 4 divided by 2, and I would get my common ratio of 2. Okay. So the common ratio is just take the next term and divide it by the prior term, and that shows you how you went from the prior term to your next term. It shows you what the jump is. Okay. So we have times 2 here. So let's see, what should I put in here? Let's double check we're right. 2 times 2 is 4. Good. 4 times 2 is 8. Good. 8 times 2? 16. Good, Haley. Perfect. Nice. Haley's knocking it out. Then times 2 again, 32. All right. They're just logic puzzles again. We just have to first get in the mindset, okay, we're not adding, subtracting. With geometric, we are multiplying or dividing to get to our next term. Okay. So what did we find our common ratio to be? It is 2. You don't even have to say times 2. It's implied that it's a geometric sequence, so you're multiplying by 2. Okay. If the numbers are getting smaller, and it started at 32 and then went 16, 18, 4, 2, right? My common ratio would be 1/2 because I'm multiplying by 1/2 to go backwards. Okay. So what I was saying right now, if it went 32, 16, 8, 4, right? We had to find the next number. What we're multiplying here, our common ratio, our ratio is 1/2. We're multiplying by 1/2, 32 times 1/2 equals 16. And remember how we could find the common ratio. If I'm looking for the ratio, it's really just the next divided by the prior. So in this case, we would take 16, we divide it by the prior, 32, we'd get 1/2. So however you figure that out, right? Just know that when we have fractions as our common ratio, it gets smaller each term. It just gets smaller each term. Okay. Let's see. Hey, if you want to take a screenshot of that, just going over this first part, go ahead and take one sec. Call this is like a side example. Okay. All right. And go ahead and take a screenshot if it helps you. Remember, just make a folder on your desktop, name it M1, and just throw all your screenshots in there. Because by the timestamp, you'll be able to figure out what's what. All right, so here our common ratio was 2. We figured it out by the next divided by the prior. Here I just did them in opposite order to show that the common ratio is a half, which we found by next divided by prior. We got it again. Okay. Now, let's go on to this next bit. Because here, hey, it's the same exact thing. We use recursive to find the next term. And all it's saying is, look, the next term is going to be the prior term times the common ratio. The explicit formula we use to find the nth term, and that is taking the first term times the common ratio raised to n minus 1. So if I was looking for the 10th term, it would be a sub 10 is equal to the first term times whatever the ratio is. And then this exponent, since I'm looking for the 10th term, it would be 10 minus 1. This exponent would be 9. Okay? So we're just going to have to plug in and be real careful about it. All right. Hey, give me a thumbs up, sideways down if you see where this is going, how it's connected to Tuesday. You see where it's going? Yeah? Okay, we're going to keep it up. We're going to get through it. No problem, okay? All right. Now let's look. What do we have to do for this? Write an explicit formula. Find a sub 7 for this sequence. So look, I know that a sub 1, a sub 2, a sub 3, a sub 4. I need to find a sub 7. And I'm gonna do that by creating an explicit formula. All right. So let's see. What are we going to put for this? Let's just make our straight explicit formula to start. Again, this is in your workbook on page 237, number 1. Let's look at our explicit formula here. I'm just going to rewrite it. Okay. Now let's see, we do know a sub 1, so let's put that in there. A sub 1 is 3. Now if we find r, we're going to leave this n minus 1 up here just like that, because I haven't been told, while I'm just making the explicit formula, I'm keeping it out of my mind that I'm going to try to find the 7th term. I'm just creating the explicit formula, so I'd be able to plug in any value to find any of the terms. We need to find our common ratio to start. How did we go from 3 to 1.5? Tell me in the chat, what do you think? How did we go from 3 to 1.5? What did we multiply by? Good cadence. Hey, if we didn't know, we could find the common ratio by taking 1.5 and divide it by 3. We get the common ratio of 1/2. Now, it's not negative. It's not negative. It's not negative. Because if I multiply 3 times a half, I get 1.5. If I multiply 3 times a negative half, I would get negative 1.5. You're thinking about it as being negative because in our prior lesson, when the numbers went down, we were adding or subtracting, so it was correct to say we were subtracting. But here, our only option is to multiply. And to go from 3 to 1.5, we multiply by 1/2, not negative. Nice. So I know my rate. I'm going to put that here, 0.5. A little easier with decimal.
I have a question.
Perfect.
Could you, instead of always having it be like multiplication, could you do instead the common, like the ratio, common ratio? Could you do 2, like divided by 2?
Could we do 2 divided by 2?
I mean, no, like divided by 2, like as the common.
I see.
Ratio.
I see. You know what? I see. That's a good question because as I was saying that, it came up as confusion because you know what? We're gonna at the top get rid of divide. I was trying to give the 2 operations that are involved, but we're always going to express a division aspect in geos. We're going to always express it as a multiplying by a fraction. So I see what you're saying, and that would be a way you could do it, but to keep it really uniformed and always think about multiplication, that's gonna be a more direct, like, path of least resistance to getting these. But I like that you're thinking like that. That's great. That's great. Okay. Good question. Great question. All right. So let's bring it back. I hope that maybe even answered a few people's questions out there. We have our explicit formula. So now I have my explicit formula. What's nice about explicit formulas is now watch, a sub 7 is just going to be 3 times 0.5 raised to the 7 minus 1. I love it. Geos are easier than arithmetic. Geos are actually easier. All right, PEMDAS, I'm going to reduce what's in the parentheses to start to the 6th power now. And then get out your calculators, because you have to do 0.5 raised to the 6th power, and that is going to require you to know the syntax for it. But you guys have used the calculators now for a minute. You guys have it, I think, pretty well. 0156. You know, there's no harm in putting extra digits sometimes. I'm going to go ahead and put some extra digits. That's what my instincts are telling me here. Times 3. A sub 7 is equal to 0.047. Yeah. All right, we did everything we needed. We found the explicit formula. We found a sub 7. So now I'd be able to put that here, 0.047. Let's see, does this make sense that it's a really small number? Yeah, look. We took 3, we divided it in half, we divided it in half. Getting smaller, divided in half, we're going to have, 5, 6, and then here's 7 divided in half. But we use the recursive formula, explicit formula, and then we can plug in any value we need. So tell me, what is a sub 17? Same recursive formula. It's going to be small, very small. Because we're dividing in half 17 times, it's going to be very small. Okay, so first we're going to take that 0.5, raise it to the 16th, times 3. Oh my God, I'm sorry. 0.0000046. You see? Once you have your explicit formula, you just have to plug in the term you're looking for. That's what makes it nice. That's why it's useful. Okay. And once you get your recursive formula, you could plug in a sub 1 if you're trying to find all your terms from 1. You plug in 1, right? You plug in 2, you plug in 3, you plug in 4. You're going to end up just finding all your parts. So these explicit formulas, if I had just taught you explicit formulas, you'd be able to do all of this, because explicit formulas can be used in different ways. You could find every single term. Okay, we need to press on. And this right here, I'd really like for you just to go up here and just write the explicit formula. Just write the explicit formula. And then we'll put 4 blank spots here. 4 blank spots. And there's a couple ways to approach this. If I just need to fill in these, I think if I found the first, a sub 1, I'd be able to put it in here. And let's see where, whoops, it's on the other side now. So I'm just going to copy these down again so you guys can see them. Explicit formula. Okay. So look, we have information already about this. We know we're given an explicit formula, which is based on this as our model. So what is a sub 1? Tell me in the chat. What is a sub 1? We got to match it with what we're given up here. This is an explicit formula. This is our, yep. Good, Mia. Anyone else? Good, Abby. All right, Cadence. Perfect. Haley, good. You guys are on it. Love it. Look, a sub 1 is always going to be the first term here within our formula. Formulas are kind of like a map, right? So I know R is 1/4. A sub 1 is 2. So I'm going to put 2 here. And we actually also know our common ratio. Our common ratio is 1/4. So what I can do is, I could work all this out, plug in a 2, work all this out. Or I can just think about this as my common ratio is 1/4. So what's 2 times 1/4? 2 divided by 4. 0.5. Okay. And then I'm going to also multiply again by 1/4. And I get 0.125. Now to find a sub 8, we need to do a little bit of work. We need to take the formula they gave us. And we need to plug in 8. You see, once you get your explicit formula, just go right at it. 8 minus 1. Okay, find what goes here. A sub 8, what goes here? A sub 8, and tell me in the chat. Yeah, it's a lot of zeros in there too. It's small. All right, tell me in the chat if you got it. How did you get 7 for the exponent? Well, since I'm looking for the 8th term, I plug in 8 as my in value. 8. 8 minus 1 is 7. Okay, looks like... Interesting. 3.5 is not correct. There you go, Mia. Yeah, it's a really weird number. It's like 0.000122. There we go. All right, Haley, Denise, Mia, Vivian. Looks good. Now, if you got 3.5, I'd have to think about that. Why that happens? Because we're multiplying by 1/4, it's going to get smaller and smaller. Maybe this was a calculator issue. So look, I'm going to put in 1/4. Hello? Oh, it's just delayed in the video. 1 divided by 4. Okay. That's this. And now I need to raise it. This is the exponent button. Raise it to the 7th. And then I need to multiply it by 2. There it is. A sub 8, 0.000122. We'll keep it at that. Okay. Yep, I figured. Didn't square it. Nice. Good deductive reasoning. Nice job. Yeah, I agree. If you end up 3.5, you took 1/4 and you multiplied it by 7. That's not it. We're not going to do that. Look, it's an exponent. It's not 1/4 times 7. It's 1/4 raised to the 7th.
What did you do to get a to the 8th?
Why? Why was I looking for that?
No, but how did you solve this 2 times 1/4 to the 7th power?
How did I find the answer from this?
Yeah.
No problem. Look, I thought about PEMDAS. I looked parentheses. There's nothing more to do in the parentheses. Exponents, yes. I have to do exponents first. So I have to apply the exponent to 1/4.
Okay.
So yeah, when you apply the exponent to 1/4, you get a big old decimal. You get that answer, and then all you have to do next, multiply by 2. Right? So that sounds like a PEMDAS issue. Good reminder for everybody. Yeah? Does that help?
Yeah.
Okay. Okay, thumbs up, sideways, down. Are we seeing? Are we connecting? How are we doing? Thumbs moving around a little bit. That's okay. It's okay. We got some time still. Good. Got about 10 thumbs up here. Okay, just because of time, I'm going to go ahead and finish this up here. This is the last type of problem that you'll have. Okay. Now, here, let's see. You probably have to write this out. Just write it out, these first 2 lines here, okay? Just write the first 2 lines out quickly. And these things we'll be able to add in as we go through them. We're not going to speed through it. Okay, so just given the recursive formula, a sub n is equal to a sub n minus 1 times -3. We know a sub 1 is -3. Find those 3 different things. So it's going to be helpful, first off, to have that recursive formula ready to go. And I'm going to write it here and remind you, the recursive formula, it's the first one, is a sub n is equal to a sub n minus 1 times d. Okay, so keep in mind that we're keeping in mind this, or we're accessing what we know, the map of our recursive formula, to pull information out. So we need to know the common ratio. We need to make the explicit formula. We need to find the first 3 terms. I think we already know the first term. That's given, right? First term given. All right, another like 10 seconds just to get those first 2 lines out. We'll do common ratio first. So if you want to write common ratio, have that ready in your notes. Okay. Nice. All right, let's see. What do we know? What do we know? We're given this recursive formula. We know a sub 1 is -3. Look. Oh, yeah. A sub 1 is -3. Now, let's look. We are given a recursive formula. We have our map here. It looks like the common... Wait, why did I write it as D? Uh-oh. Oh, that's just an error. Whoops. I was in the past. Most of the time I'm in the future. I'll be in the present. That sounds better. Times R. Whoopsie. So I know what the common ratio is. The common ratio, they gave it up here. You see? They gave it right there. The common ratio is also -3. So what this tells me is we're going to be multiplying by -3 to get to our next one. So you may already know what goes there. If you want to fill these in, you could do it that way. But let's look at our explicit formula. Let's try to create our explicit formula now. Let's see if we have enough information. The explicit formula is a sub n is equal to a sub 1, I know. A sub 1, I know. It's -3. The ratio, the common ratio, I know as well. Common ratio is -3. And then this n minus 1 stays there. Boom, boom, boom. You see? All I did was plug in I plugged in my a sub 1. I plugged in my ratio. I leave the n value in there because I can now find any value, any term I want. What's going to be our second term? You could plug it in here too and work it out, or you can just multiply by -3. We're going to get +9. Multiply by -3, and we're going to get -27. Okay. So just looking what we did, we were given a recursive formula. That, looking at my map, helped me see that the common ratio is -3. I know my first term is -3 as well, so that's why I put -3 as my first term. Common ratio is -3, so when I write my explicit formula, the ratio is -3. The first term was -3. So I leave it just like this. I could have used this to find A2 and A3, but I multiplied -3 by -3, got 9. Another -3 got -27. And we're done. We're done. All right. Good, Haley Cadence. Good feedback. All right, give me a thumbs up, sideways down for this lesson. Remember, you got 2 weeks to finish it. We'll come back on Monday. We'll look over it again. So just, hey, maybe even just get it started. Good job. Maybe just get started. I'm gonna let you guys out 5 minutes early, and stick around if you are someone that needs some extra help. Okay, so I'll stop the video.